been listening to track number 2 from the album A Future Long Ago by Terracotta Blue from Magnatune.com. Did you know that for only $299 you'll get lifetime access to the Magnatune Music Library?
Good morning. Can you hear me?
Yes.
Awesome. All right, I think, let me see. Yeah, we have enough people now. All right, we can get started. Good morning, everybody, or wherever it is in the world for you. For the agenda, the first thing is Metropolis, and the first sub-item is Peter talking about EIP 86 or 208, transaction abstraction, and specifically about how contract addresses cannot be computed without a live blockchain, and there's no guarantee that the deployed code is ours. So Peter, you can go ahead. Great.
Old plain account, I send an old plain transaction to create a contract, then the address of that contract will use the new scheme, starting from Metropolis. And this actually has quite a few drawbacks. One of the drawbacks is that this new contract scheme only depends on the init code. So currently, in the entire ecosystem out there, every contract is based on some form of the owned contract, which kind of just takes the message sender and assigns that as the owner. Now, since for example, if I'm going to deploy a wallet, that means that starting from Metropolis, if I don't specify some init code that explicitly sets me as the owner, then me deploying a wallet and somebody else deploying the wallet will actually result in the same address, same contract address. Now, of course, in theory, it will fail for one of us. The problematic part is that, for example, I deploy my wallet, it succeeds. Then a malicious miner deploys the same wallet on an alternative chain. And if the miner gets lucky and there is a reorg happening, then that will actually result in me losing ownership of that address. Now, if I'm not prepared that such a thing can happen, then I actually might end up not realizing that somebody else became the owner of the same contract that previously I was rightfully assigned as the owner. So this is one of the problematic parts. The other problematic part is that currently there is a lot of code out there that can actually calculate contract addresses client-side. For example, our repository also contains a code generator, or a binding generator, which has a deploy function. And when you call it, it will immediately tell you that, hey, this will be the address of the deployed contract. And then later on, you can eventually poll whether some code was deployed to that address or not. Now, with the new scheme, that's basically not possible. And let's say, so the problem is that I cannot really decide if the code deployed there is actually a result of my transaction or a result of somebody else's transaction. So and I cannot actually calculate what the final So I can calculate what the final address will be offline, but I cannot calculate it. I cannot for sure say that it will be my contract. So this is problematic because it's going to break every single client out there that depends on such logic. And furthermore, I had one more problem. Yes. So the last problem was that from this point onward, we cannot calculate contract addresses without having access to the blockchain, because depending on whether we're in Metropolis or Homestead, the contract address will be different. And this is, again, in my opinion, problematic, because I don't think any client code out there that does contract address calculation has an idea of what the blockchain state is currently. They just take the transaction and can, or even you don't even require a transaction. You just need an account and a nonce, and you can get a contract address. So these were my issues that I see with swapping out the contract deploy address for old plain accounts and plain deploy transactions. And I also had a suggestion how we could do this. I pasted that in here. And the idea would be that if the sender of a transaction is the null sender, then we can switch to the new scheme, whatever new way the EIP figures it wants to generate new contract addresses. Whereas if the sender is not the null sender, then we just keep to the old one. And basically, this could be enacted immediately, because since nobody has access to the private key of the null sender, nobody will be able to hit the new account derivation path. And inversely, even if Metropolis hits, every code out there that exists will continue to function properly, because the only account that will actually break is if somebody is sending from a null sender. But to do that, you need to actually send the new abstract transactions without the sender account. And to do that, basically, then you must rely on the init code, because there's no message sender that could differentiate the owner. So that's in short.
Yeah, so I mean, in general, I'm definitely inclined to agree that making the new address scheme only apply to create to and to the specific null sender case is the kind of much lower risk way to do it.
Well, the question is there any value in breaking the old scheme?
I'm inclined to say that there's value in retiring it eventually for simplicity, but that probably should be much further up, planned much further out than the 2 months that Metropolis will be released in.
Well, sure, but I'm guessing that eventually, if we retire old accounts, then the old address scheme will be retired at the same time, because you won't be able to do such transactions. So it makes sense to me that while we are supporting the old type accounts and old type transactions, it would make sense to keep the old functionality as is.
At this point, I'm inclined to totally agree.
Anyone think it's a bad idea?
No, I'd like to speak out in favor of it. I think it's a really good idea, because there are really sneaky catches with the way it's currently proposed. I think it's really good of you that you caught these.
Sorry, I know the problem, but I missed the new idea. What's the replacement suggestion?
So the suggestion was that for all existing plain accounts and plain transactions, we keep the current addressing scheme, and we only switch to the new addressing scheme for create to, and if somebody is using the null sender, meaning a new transaction.
So I'm worried that these problems, like that will alleviate the immediate issue, but I'm concerned that these problems will extend to effectively any use of the new scheme, and that we need to back off and see whether we can, whether this issue persists in general, and also that as long as, like, we're still going to have the issues with transaction IDs no longer being unique and addresses no longer having invariant code as long as it's possible to issue such transactions.
So I think that's the topic, a new issue that we've been discussing. Maybe Nick, you can quickly summarize that, because that's a different issue.
Well, I think it's, it's tied in anyway. I guess my concern is that we've inadequately explored the consequences of breaking a couple of key invariants in Ethereum, one of which is that transaction IDs refer to only 0 or 1 executions of a transaction, and one of which is that addresses that have code, that code never changes except to be deleted. And I worry that these new changes will have a big impact on the ecosystem, particularly the one about transactions potentially having multiple executions.
Okay.
Yeah, so there are kind of, I guess, multiple things to discuss here. One is if we should make some change to E208 in favor of like Peter's suggestion. The elegance of that, in my opinion, is that we could basically implement that right now and roll it out in the clients, and it doesn't have to have a hard set number where we roll it over. Just sneak it out. And the other is that there are some of us who are concerned about the general E208 in general and the consequences of that. So it's kind of two separate discussions, I guess. Does the parity team have any thoughts about these issues?
So yeah, I would agree with Peter on the particular issue that he has mentioned.
And regarding the transaction possibly being able to be mapped to multiple executions, I'm not sure.
Well, I personally don't see that being much of an issue as long as there is a notion of canonical execution.
Why, yes, but what is the canonical execution? How do you define it?
Well, that's up to a miner, I guess, whatever regex they use to detect if they need to mine a transaction. Basically, they have to decide if a second execution will be profitable to them.
So it's not necessarily about being profitable or not, rather whether we open up a vulnerability where a miner could, for example, execute a transaction 10 times just to screw with the clients.
So to give a concrete example, say you're sending funds to an exchange and the miner first mines the transaction before it's time for that nonce, which means it's included in a block with no effect. And then later at some undefined time in the future, it's mined again and has effect. How does the exchange know whether the transaction went through?
So for example, if a miner mines a transaction that essentially reverts now, the exchange will think at least that the transaction failed, and maybe the miner will add it half an hour later. And if the exchange doesn't know that a transaction that previously was failed could actually get included later, then it might be really messy.
I mean, we already talked about that some meetings ago, that that account code should signal one of 3 situations. The first situation is this transaction is invalid and you can delete it from the mempool or from the pool. 2, yeah, transaction executed successfully and miner got rewarded or whatever. And 3, transaction execution is invalid, but it might get valid in the future. And I mean, these three cases can only be detected by executing the transaction.
I remember that we talked about it, but I don't remember explicitly those three cases. Is that documented anywhere? What the idea is, how to implement that?
I think that was audio only.
Yeah, I have the notes though. Let me find those and I'll put them in Getter in the chat.
I mean, the successful version is obviously no reversion. And the two, I mean, we have basically two different failure cases. And I would say in both cases, we have a revert with different, error message, revert data.
Then again, what happens if a transaction can be executed multiple times successfully? Let's say 3 times.
I mean, that will, we cannot, successfully. So yeah, sure, but what's the problem? Assume you have an account which does not use a nonce scheme, then that's what will happen. I mean, I don't know, a faucet, for example. A faucet could be an example.
So one realistic example of literally the exact same transaction being executed multiple times that I could see happen eventually is if there's some contract that triggers the alarm clock. So let's say if there's some contract that basically just triggers some bounty in exchange for pinging it and getting it to do stuff, and the party that would most efficiently be able to do the ping is basically miners. So what miners would do is they would just include a dummy transaction with no signature that just includes that to address, and then that transaction pings the contract, it does its thing, the miner gets paid, and that's like a blob of data that could get included a bunch of times.
Yep. But in this specific scenario, we can have actually multiple canonical executions, which means the entire ecosystem needs to be aware of this possibility. Mm-hmm. So we are kind of just worried of the implications, and we should probably try to figure out what this would be on exchanges on various participants in the ecosystem.
So I believe let's see. I mean, I know that in general, if users should be able to insulate themselves from the possibility in a lot of cases. So, like for example, if you have a regular account, then none of your transactions will have multiple canonical executions. And so, what could happen is multiple executions of a transaction get sent where both of those executions lead to your own balance being increased. Yeah. Although I think in general, like if I think it is probably worth it to think like basically major use case by major use case. But like in the case of an exchange, for example, if it ends up getting money because of a transaction being repeated twice, then the way that the exchange should securely implement itself is by looking through logs, and like the log would clearly get triggered twice and appear in 2 different places.
But realistically, that's not how existing exchanges operate. They mostly still
right. I mean,
transaction records.
Yeah, I mean, yes. So I mean, the way the way current exchanges operate is basically, and a lot of them, they just look at transactions, and so if you send money to them from a contract, then like they have no idea that the deposit happened until the next time they do just an entire balance sweep, which might be once a day. So I'm not. So like that's a status quo that I think will end up existing with or without anything we do, at least until we manage to like get EIP86 accounts fully adopted with logs inside of them by default.
I think it's, I mean, the main thing that prevents exchanges from adopting more sophisticated ways of receiving funds is that most wallets don't support them, or sorry, not most, but a significant number of wallets only support sending bare transactions. And historically haven't done a very good job at sending enough gas for log calls to execute. And of course, they don't want to deploy a copy of the contract on every single user address when they invent them left, right, and center.
And then we also have the cases where you transfer not Ether but tokens, and they have no ability to have the custom logs.
Well, in that case, though, the token contract itself is supposed to log the arrival.
Yeah, hopefully, but they can, the exchanges can't really enforce that.
Well, they can. They can refuse to list any token that doesn't log correctly. I'm just, I increasingly think we have to find a way to preserve the invariant that a transaction ID refers to a single execution. I worry that this will disrupt a far too large proportion of the ecosystem.
Were there other comments on this?
I mean, what happens if we require... Okay, sorry, yeah. We have to... So to enforce that with new style accounts, we can add the requirement that transaction IDs are unique, which, yeah.
But then, like, how do we do that without putting basically an entire, like, ever-growing map of transaction IDs somewhere into the state?
Exactly, that's what I wanted to say. And furthermore, we also have to require that transaction included cannot revert. So at least these new style transactions, because reverting is their way of signaling the nonce is not correct or whatever they use. So I think that's really hard to achieve with the new style accounts.
I don't think you, well, yeah, I don't think you necessarily have to enforce that they can't revert, but you have to have some, yeah, you don't necessarily need a mapping of all transactions, but it means you need something like a nonce or a hash of a previous transaction or some other field that can't be repeated.
So, I mean, the other thing that the other approach is to try to resolve this at, like, eventually I think it'll have to be resolved at kind of higher protocol layers at some point. So, like, for example, something like a instead of just providing a transaction hash, you might provide a transaction hash plus block number and transaction index or something similar. Though, like, I mean, like, the machinery for that would take longer, but it does seem like the sort of more general solution.
But I mean, the deeper problem here is that the transaction hash should already be unique, even for transactions that are not included in the block yet. Or is that not an issue?
Yeah.
So there's two things that are being identified really. There's the transaction, which is the message, and then there's the execution of the transaction. And currently those two are synonymous because every transaction has at most one execution. And that's the invariant we're breaking, and why you now have to, yeah. Anyway. So I mean, to some degree, we do already have a stable identifier for execution, which, as Vitalik observes, is a block number plus a transaction ID or a block hash plus a transaction ID. It would have to be a block hash, actually, because otherwise a reorg will invalidate it.
Yep.
But that's not how most people refer to executed transactions. And most systems, I suspect, index transaction executions by transaction ID because they implicitly rely on that assumption.
Well, that's the only meaningful way, because so if I create a transaction, I know the transaction hash, but I don't know anything else. So I need to be able to look at everything else based on the hash.
What would be the consequences of requiring new style transactions to have a nonce, but still allowing them to specify their own verification schemes?
So requiring new style transactions to have a nonce, and which nonce would it be though? Like what would the rules for the nonce be?
So the nonce would still be specified in the outside transaction, but the rules for validating everything except the nonce would remain the property of the account.
So basically, they would do what? You would check the nonce against the two accounts, and then you would increment the nonce of the two account.
Yes, I think so. Yes.
I mean, if absolutely necessary, that does solve the problem. Although, in the long term, I would very much like to try to move away from that sort of stuff being necessary.
I mean, my own inclination at this point is to suggest that while it may be possible for us to break this variant about transaction IDs in the future, I don't think we have enough time to before Metropolis to consider it seriously enough to make sure we're not going to break things. And I don't think the community, places like exchanges and Etherscan and so forth, have time to fix their assumptions about this variant.
And would this only apply to account abstraction? Or the EIP 86, I mean?
Yeah.
Okay. Okay, so, we can bring this up at the EIP level, but yeah, it sounds like there's enough concern that it's warranted to look at that again, I would say. Does anyone else agree?
By the way, I think Nick's proposal might be a good compromise in that you keep the uniqueness invariant, but you still achieve every other flexibility that the EIP attempts to achieve.
So then exchanges will be able to screw up other accounts.
Although one question with that approach though, which is that if, let's say, you send a transaction and a malicious miner includes, all right, no, never mind. Like if you send a transaction, then like it would become invalid to do things like including it out of order.
Yes.
So that will enable miners to effectively change other account nonces, right?
Right. Yeah. No. So this definitely is a concern. So like miners would be able to basically include EIP86 transactions going to arbitrary accounts, and those accounts would be able to and like they'd be able to just like arbitrarily push their nonces up, and that way make require people to resend transactions.
So is the best course of action taking this to an EIP for some type of proposal to be written up by Nick or anyone concerned, or is there an alternate way to deal with this?
I don't really think we have a solution ready for this. It's
Yeah.
just a concern.
Yeah.
Okay, sounds good. All right, I think we should move on in the agenda regardless. Something though, I think as we go on, let's revisit this near the end so that if anyone else has any further comments, and then maybe by then we can, no one is going to have a full solution, I'm sure, but we can still move on from here and then come back to it to say what we're going to do. So I believe that goes through agenda items 1 and 2. Peter, is that correct? Did that cover kind of all your comments?
Yep.
All right, great. Oh, well, there's a second 2 in the agenda. I'll have to fix that. But it's the EIP 86, so same EIP, and this is about the ECDSA account abstraction and transaction origin. I don't think Jeff's in here, but can anyone speak for any progress that's happened on that discussion? Yeah, I actually haven't had a chance to look at it, so we might have to skip that if Jeff's not in here. Alright, cool. Yeah, we can just skip that one. I think there has been some discussion back and forth, though. Let me see what the last comment was. Because, yeah, I think there was, like, some people who still wanted transaction origin. Oh, yeah, actually, the last person who mentioned it was, let me see. Let's see. Yeah, the last person who talked about it was Jeff about a week ago. So I'll get back with him on that and just see if he has any other comments or stuff on that. The next one is the difficulty bomb. Afri from the Parity team and Stack Exchange pointed out that we don't have an EIP for the difficulty bomb. So does anyone have a recommendation on that? And actually, before even that happens, can anyone answer me? Would that be related to EIP 186 with the ETH issuance, or is this going to be a separate thing?
So I mean, I think I may have made an informal proposal at some point, which is basically that we like in the formula that computes the difficulty, we replace the block number with a function that says if pre-Metropolis, take the block number, if post-Metropolis, take the block number minus like 2 million or 2.5 million, and this basically like just cleanly delays the thing by like a year to a year and a half or however long we choose.
That sounds reasonable. Well, I was going to say it's a discontinuity, but of course we want a discontinuity, so yeah.
Yes. Mm-hmm.
Okay, sounds good. Any other comments or suggestions on that? Otherwise, we can... I actually am not even positive that should be its own EIP. Well, I mean, I guess it needs to be because it's a whole separate thing we're doing. It's not really related to any of the EIPs going in, right?
Mm-hmm.
Cool. All right, any other comments on that? Otherwise, we will get a PR together once. And actually, yeah, Vitalik, if you could summarize that either just in a comment on the EIP or something, or write your own PR for it, that'd be great.
A comment on EIP 649?
Exactly. Or open a PR for it. I didn't know if Afri was going to, but so either one of you can.
I'll just comment for simplicity.
All right, great. Thank you. Okay, that's all for A, and we'll go back to 86 in a bit. So topic B under Metropolis is updates to testing. So 2 weeks ago, we hit the ground running on bringing in outside collaborators and new people to help with testing. And so I believe both Yoichi and Dimitri are here. So we can just have Dimitri start. If you want to give an overview of some of the testing and people coming in, and then I'll have Yoichi and then Martin if he wants to chime in as well, anybody who's been involved in that. So Dimitri, go ahead.
Hi there. Do you hear me?
Yes, I can hear you.
Okay. I was basically focusing on a test that we already have, and Yoichi updated, made a lot of pull requests to updating the command line interface of test if. And we opened a support channel on GitHub, both on GitHub and Skype for the newcomers. Currently, I'm working on updating blockchain test to kind of more general format. And there is also a possibility of making a fast testing, which we were discussing with Casey and Martin Slender.
Yeah, I can chime in on that. So the fast testing is basically that we can do directed fuzzing against the EVM binaries, which are there is a common format implemented in Geth and Parity, and also by Ethereum. We don't have C++ yet, and these tests will be a lot. I mean, it will be a lot lighter and quicker than the existing test process with manual crafted tests. And I'm hoping that Matthew DiParante here can help out and join in on doing these, setting up these tests.
As there is a new feature, it's not exactly new. With the test if you could now produce randomly generated smart code for EVM. It should be a correct code with random opcodes.
Okay, so I think, Yoichi, did you have any comments or?
No, not much. Dimitri covered it.
Okay, great. Oh, and lastly on the testing piece, Casey just released a post and a walkthrough video that's really good about testing with Ethereum JS. Casey, if you want to just give like a quick overview of what that's about and how people can look at it.
Sure. It's just to kind of celebrate the milestone of reaching Homestead compatibility on Ethereum JS VM, and trying to encourage contributors to help out with getting up to Metropolis.
Cool. Yep. So that's on Reddit right now, and yeah, it has some good links if anyone wants to jump in and get involved in that. So yeah, that is pretty much it for testing. Was there any other comments on that? Okay, great. So next is the details on implementations of the EIPs. I think Geth and Parity are pretty much done. So just looking here, I'll just go ahead and say, so Parity, are there any problems, issues, or questions with how you guys are implementing EIPs, or is it pretty much the same as last time?
Yeah, not really. Not much progress since we're still waiting on the test mostly.
Okay, great. And then Peter, Geth.
So as far as if you look at that PR, it's quite a massive PR from Jeff, and so if we began reviewing it, it turned out that it's a bit large as a single PR, so we're mostly splitting it up into smaller pieces, and we would really like to start merging in individual pieces as we go along. So basically, we'll probably pick the easier PRs, which probably won't change. I mean, easier EIPs, which probably won't change anymore, and just start merging those in, just so that the code base doesn't diverge. So that's mostly what we're doing.
Great. Did someone else have a comment, or was that background noise? I couldn't tell.
Probably background noise.
All right, great. C++ Ethereum, Christian, or yeah, I guess Christian.
I think Andre has a better overview.
Oh yeah, that's right. Sorry, Andre.
Yeah, we implemented grade 2 opcode, made some improvements in block hash implementation, some fix in static call. So in general, currently we are also done with all the EIPs and waiting for the finalization and the tests.
By the way, this static call change, did you make all the other clients aware?
I don't know much about it. Maybe Yoichi knows something.
I was wearing the headphone and I put off the headphone and so on when Christian asked the question. What was the question, Christian?
There was a subtlety in static call which was implemented incorrectly, and I wonder whether we made all other clients aware.
There I haven't done anything. Yes, I think I should check.
We keep the new test in the develop branch of the test repository in form of general state tests. So other clients who are running tests run it from develop, and if there are any changes, so you could ask on Skype test channel, because once we did an update in CDP Hero, we also update the tests, and you could see if you have any changes in the tests or problems, you could ask what's happened.
Okay. Sounds good. I think, did that answer your question? I forgot who asked it at first, actually. I think it was just kind of an ongoing conversation. Okay. Yellow paper, so Yoichi.
It's done except for the gas cost of the elliptic curve additional and scalar multiplication.
Okay, great. That'll be the next thing we talk about is gas price estimation. Oh, and then finally, Pythap or Pytherium. Actually, Vitalik, what do you prefer for the Python client to be called? Because I've heard Pythap and Pytherium and all kinds of stuff.
Pytherium is the library. Pythap is the client that connects to the network.
Okay, got it.
I'd say just Pytherium is probably
easy. Okay, cool. So what's the update on that?
I mean, it's passing all pre-Metropolis tests. I've also used it to implement stuff like in like an on-disk state cache and state tree pruning, and that seems to have had fairly good results, and it's surprisingly not that complicated. It's I mean, it was passing a lot of the Metropolis tests, although more recently I've kind of let that slid back a bit on that because I'm basically just like waiting for C++ to for like all the C++ tests to be there so I can just try it against all of them all at once. And also I remember that like last time I checked, there were a few there were a few tests that I ran into where I was failing, and when I dug into them, it was because it was C++ that made the mistake. And I've been waiting for C++ to basically fix at least the mistakes that I know about. So like one of those, for example, is that I think there was one test that reverts a some kind of operation that basically that puts a new puts a new piece of contract code in place, and it was this weird edge case where you have a contract with code A, then the contract suicides, and then the something else with code B gets put in, and then if both of those operations get reverted, then like what should happen is the code changes from B to A, but instead it changes in C++, it changes from B to 0.
Yeah, that should
be okay.
Did you say that was fixed, Andre?
Yeah.
Okay, great.
Okay. If that's fixed, then great.
Okay, cool. So the next thing is determining gas prices for new opcodes. Martin, I saw you were starting to do that. I think someone else might have commented on that too. Arcady might have had some stuff. So, Martin, since you've been talking about it the most, I'll let you take it away.
Yeah, so this is mainly just a discussion point. We've started getting, we have some benchmark data now for Go Ethereum. Arcady produced some similar benchmarks for parity. I think someone somewhere generated for CPP, and kind of the question is, how do we move on and actually determine the gas prices, and when do we decide on that? I mean, it's an implementation details for the client developers, but I think for generating the test cases, it would be good if that could be kind of set as soon as possible.
As far as organization of the conversation goes, basically as a comment in the EIP might be okay, as long as we stay diligent to look to see who's agreeing on what on the gas prices. Is there any other I mean, even for something like this, it could even be as informal as just being in the core devs channel. So yeah, I don't really care. Either one would work for me. Does anyone have a preference or suggestion? Oh, hey, Daniel, your mic is really scratchy and loud.
Is it better now?
Yes, works great. Go right ahead.
Okay, so I made the comment a few weeks back about the gas price of the modular exponentiation, that it shouldn't be quadratic in the modulus. Has this been looked into?
Yes, Danny, that's
yes.
one of the things. Sorry, yeah, I wanted to measure that, but I need someone to provide me with the inputs to be able to benchmark the differences.
Dan, can you repeat your question again, please? I didn't fully get it.
Okay, so I made a comment a few weeks back on the gas price of the modular exponentiation, that it shouldn't be quadratic in the modulus because the most of the libraries of arbitrary precision arithmetic, for the kind of numbers that we're talking about, they use the Karatsuba method for multiplication in exponentiation as well. So that is much less than quadratic in the length of the modulus. And I think it would be unfair to penalize people for using safe and long moduli and encourage the use of short moduli with the basically what amounts to subsidized gas price, which is what happens if it is quadratic in the size of the modulus. And then I think it was Martin who said that he's going to benchmark it to see whether indeed it grows slower than quadratic with the length of the modulus. But at some point, I think this project either got dropped or gets stuck on some impediment that I'm not aware of.
Yeah, so the impediment is that I made the benchmarking framework, but I'm not the mathematician, so I don't really know the inputs to measure the inputs that you want measured. So I need some feedback on that. Yeah.
And I can provide that, although actually I think there should be some pretty decent inputs inside of the Pi Ethereum tests already. I can see if I can grab that. Hold on. Precompile tests tab. Actually, yeah. Here, I'll just first check the Python file to see if Okay, yeah, so right, okay, so we have some tests for the around 2 to the 256. We have tests for around 2 to the 1024. I mean, like basically, I think the simplest thing to test is just like make a random number of n bits, and then raise that just like, I mean, try raising it to the power of 2, try raising it to the power of 3, try raising it to the power of like some, I don't know, like a billion, and then try that with various lengths going from, let's say, like 1 byte, 32 bytes, all the way up to 4096 bytes.
Yep, that sounds reasonable, and I think that would
Yep.
answer the question.
Okay, so yeah, Martin, I would say yeah, if that suggestion works, great. If not, I'm sure Daniel can like give you some feedback as you're writing that particular test.
Mm-hmm.
Yeah, we'll
I
have
can
to
generate the
all
input
core
for you.
right now. I can loop back with Daniel and Vitalik.
All right, thanks everybody. The next point is, let's see. So yeah, we'll continue to talk about that in the core dev channel, and it sounds like we'll just determine what the gas prices should be through the test cases, but also if we can do comments in the EIP, that'll probably be the most coordinated that we can get for that. The next point is to review the time estimate for testing and release. So I think, Vitalik, do you happen to have like a new number on block times for the next few months?
Yeah, I mean, I did that. I actually updated the numbers yesterday, but let me rerun through that script.
Yeah, and while you're doing that, just
yeah, so our block currently 17 seconds. They will go. They will hit 22 seconds at the end of July. So on like basically on August 1st. And they will hit 30 seconds on August 28th. And they will go above 30 seconds to 38 seconds on October 1st.
Okay. Testing team, anybody on the testing team, what's the feasibility of releasing this by September, or is there a, what's the progress on that?
I would really like to see the fast testing implemented and working on the clients. I think with the fast testing, we could cover more cases that we can think of when we create tests by hand.
Okay. Oh, could you repeat that first part? It cut out for me a little bit.
So yeah, I would like to see fast testing being implemented and running against other clients for at least a couple of weeks. So we could see how the clients work on randomly generated fast tests.
Okay. Yeah, I understand that. So, as far as tests being completed for different EIPs or anything, this might be too, like, there might not be a good number for this, but is there an estimate for how far along we are in total for completing different tests for EIPs that clients can run?
I guess we could do that to the middle of August.
Okay. I think that, well, yeah, does anyone have opinions on kind of a release? I think that one thing that might help is to really wrap up, especially EIP 86, which we'll be going over again in a little bit, but I think some of those have been somewhat dragging on some of the progress that we would be making on test. I mean, I'm not actually doing the test, so I might be completely wrong on that. But I think that's good that we close this out. Kind of like the EIP freeze that Yoichi was talking about before, but more of an informal freeze for some of these. And I know a few of them are closed, so that's good. But the EIP 86 is a big one that deals with a lot of different things. So.
No.
So we'll go ahead and just, I guess I should say this. Who Does anyone think that it's still okay to give a estimate of potentially doing the testnet August and potentially releasing September, like just kind of around that time? Does that sound doable or undoable to anybody in here?
Well, I think that mostly depends on when we can finalize the EIPs, because that account abstraction EIP is really not trivial.
Yeah, I mean, for the account abstraction EIP, I mean, I can personally dedicate a lot of time to thinking about it and giving a recommendation, which will possibly be either introducing it in a limited form or basically advocating for going all the way and removing TXID uniqueness, but delaying the whole thing until the next hard fork.
Yeah, I was gonna raise that thing again, and we talked about this a couple of months ago, and I asked if there was any kind of thoughts if we would roll out Metropolis as 2 hard forks, and I'm starting to consider that being an option. To have a first hard fork where we do precompiles, everything that's really that's pretty easy to test and very well defined on how to implement. And then have second hard fork with abstraction.
Yeah, I mean,
because we have our backs against the wall with the time bomb here.
I mean, yeah. So like one example of an alternative route for EIP86, and this is one that I literally came up with during the course of this call, is we would add an invariant that says you can't have two transactions with the same TXID in the same block. Then you would require the S value of an EIP86 transaction to just be the block number. And then you would basically you just force people using EIP86 transactions to just send out a bunch of copies for like block numbers that are beside each other. So like there are those kinds of options. Like basically my concern is that if we're going to do if we end up doing a staged rollout of EIP86 itself, then if I'd prefer stage 1 should be forward compatible with stage 2, and if we can't achieve that, then it would be worth basically delaying the whole thing until we can do a proper release of it all at once.
When you say the whole thing, do you mean the entire hard fork for Metropolis, or delaying that?
No,
EIP?
I mean EIP86 plus the machinery required for users to handle it safely and preferably even actually do things like make accounts with it.
Yeah, I mean, this also presents another opportunity because I know there were a few other EIPs that didn't make it into Metropolis, but that could be potentially. I mean, that would be kind of a slippery slope to start including more EIPs for a second quote Metropolis fork. But I like the idea of 2 forks mainly because it's iterative rollout of features, and this is a real big feature list with a number of EIPs we're dealing with. So, who is there anybody who wouldn't be in favor of splitting Metropolis into 2 hard forks, and mainly to get the difficulty bomb diffused, but to have a pretty firm deadline on getting the second one out?
I remember a long time ago there was an EIP for adding new changes to the EVM, not by hard forks, but by EIP proposals. Like if you have a small EIP proposal, it's easy to implement and make a smaller hard fork than a huge hard fork with lots of changes.
The first time we were speaking about this, I think one of the suggestions was to focus on the deadline and see what we can get ready. So there are multiple things that can go into Metropolis. Some are simpler, some are more complicated. Can't we just try to figure out what we could start testing right now so that we would be confident we would be ready by September? So we keep this we keep the date fixed because that's the Ice Age. We know that at minimum Ice Age diffusion would go into the hard fork, but we start coming up not exactly with all the changes that we want to get in. Just for instance, Zkey is not a precompiler. Is that something that relates to the other ones? and we can change, and we can see which IPs are simpler or more easy to test, and make sure that they are ready by September. And to be ready by September, they must be testable by August or July.
Yeah, I think that would be fine. So, and I guess, yeah, that was a good question, Alex. I guess EIP 86, if that is taken out of the first of multiple or two hard forks, would that affect any of the other EIPs going in, and particularly the precompiles?
And it would technically make some of the privacy features marginally less useful, basically because, like, if you have a rig signature, then if you can't do things like spend from a rig signature using a null sender, then you would basically have to have Ether in an account, and then that Ether in an account could be a privacy leak. But like that's only one of the use case of this sort of tech. So
not necessarily, because it is already possible for you to send and interact with a contract without having Ether on an account by signing a message and having the contract read the message. And you can even add some other feature where the contract will send a little bit of Ether to the person sending it. So this is theoretically possible without a fork, but we are mostly worried about spam protection, etc.
Yeah, no, I mean, I agree that that's definitely possible, which is why I say marginally. Like, basically, the reason why that approach is is not optimal is there's two of them, right? One of that you would have to rely on some third-party intermediary to initially cough up the money, and the other one is that like you still incur EVM inefficiency because you're like pointlessly verifying an EC recover or an ECDSA signature on top of the ring signature. So like it's not optimal, but I agree, like it's totally fine as an initial approach.
Yeah, it's not optimal, but it's not broken, and it's something that, I mean, certainly having ring signatures is better than not having it, even if it's not optimal. And also, I would disagree that you need a third party for that, because I can sign a Whisper message, I can sign a message, send it via Whisper, and have a contract say the first person to put this contract to pay for this transaction will get X Ether. And then you're not relying. You can have a bunch of competitor services listening to Whisper messages and paying for them to be uploaded to the blockchain.
Okay. So yeah, I think y'all are both saying pretty much the same thing, that it would just provide one less specific use case, but that it can still be achieved, or the ring signature situation that y'all are suggesting could still be achieved through a different means. So that would just be making sure that the community and anybody who is implementing these is aware that it is not fully, it does not have all the original promises yet, because it would need to be further shored up in the next, the hard fork after the next one, for the features of EIP 86 to apply to the features of the precompiles that affect ring signatures. So yeah, that doesn't sound too bad at all. Yeah, so I think the two hard fork idea is good. I think between now and then we should definitely keep discussing EIP 86, but there's enough at stake, and that affects enough of the future stuff with Serenity, that I think it deserves a second hard fork now that I'm kind of thinking about how complex it seems.
If we split the hard forks, the tests should be fixed for that. Currently, all tests assume that there's only one hard fork for Metropolis. So splitting some of the changes away would mean every general state test will need to test one more network. So this is a global change that takes maybe a little bit of time, maybe a week or so to adjust.
So Yoichi, in your estimation, what's your opinion on the 1 versus 2 hard fork, kind of understanding some of the stuff that's going in and how the tests have been written from both sides?
So Dimitri has already given an estimate that the release, a timely release would be possible. And that's assuming only one hard fork, and I kind of agree with that. So I'm not seeing the need of the split right now. Although I might be mistaken that if 86 is not so problematic. I believe so, but maybe I'm wrong. If there's big concerns about EP86 or any of the EIPs, yes, that's an option. It's an option to split out later.
Yeah, I don't think splitting it into two hard forks is ideal, but it's going to depend on, between now and the next core dev meeting, how much gets accomplished with the dialogue for some of the issues brought up by Peter, Jeff Coleman, and Nick. So I think that my suggestion would be that we all focus on EIP 86 between now and next meeting, because I think there's a good chance we can work through a lot of the thought behind how to solve some of these problems. And then if we can do that, then having it be one hard fork would just go ahead as it's been scheduled. Because if we can finalize 86 between now and the next meeting in 2 weeks, I think we'd still be on track for one hard fork. And if not, and it is determined that there's a lot more complexity or problems than initially anticipated, then we can discuss the two hard fork thing again the next meeting. Any other thoughts on that?
I think that sounds reasonable.
Yeah, me too.
All right, great. So yeah, the summary of that is there's now the potential to be two hard forks. That's likely not ideal for rewriting test and a few other things timing-wise, and it would just kind of put more stress on having to do that, just because hard forks are stressful currently until we get on a rhythm. So yeah, we'll talk about that more in the next meeting, and until then focus on EIP 86 to solve some of the problems. I might even try to make a list of some of the unsolved issues and questions regarding 86 and put it in a comment and put it in the core dev channel. The next thing is the I have block gas limit increase update. I think everyone knows about that, though. A few of the mining pools targeted a much higher gas limit in the 6 millions, so the gas limit has been rising to that level. Does anyone have comments on that? Because I saw there was some discussion back and forth on some of the mechanisms behind the block gas limit increase, and if it would be a good idea to change that. I think Matt and Vitalik and a few other people were talking about it.
Yeah, so I basically just raised the points that it's, even though it is like a 42% gas limit, it's not really a significant departure from status quo, because it's like half of that is only counteracting the capacity decrease we've seen because of the ice age so far, and the other half will basically counteract the capacity decrease we'll see from the ice age until we do the Metropolis fork. And hopefully by the time Metropolis actually hits, we'll have some we'll have a bunch of optimizations in the clients and that are currently in the pipeline. So I'm not like personally worried about the consequences of making the gas limit go up. The as far as mechanisms go, like basically I think the concern is that we haven't really seen the automatic adjustment mechanism doing a very good job. And I think the reason basically is that in order for that mechanism to do a good job, first of all, either literally everybody has to be complying with it, plus the blockchain needs to be 2/3 full, or 2/3 of miners need to be complying with it and the blockchain needs to be 100% full. And realistically, we'll end up having slack in both dimensions. So one possibility, for example, is that instead of targeting 1.5 times the average usage, we could target twice the average usage, and this will make it be more willing to go up during high load if that's what we want. The other thing that that at least I want to see more discussion of is like some of these more interesting dynamic proposals that basically say keep voting the gas limit up, but then if you see a block that takes more than, let's say, 1.5 seconds to process, then cut your target down by a factor of 2 and then just like let the thing find its own equilibrium.
I really like that idea, although I think it needs to be restricted to only voting it up when your blocks are full, because otherwise, if the network's idle for a while, it'll get voted up to the maximum.
And when you say like judging by the previous processing time, is that like based on your own client who's mining the processing time? Because wouldn't that have like, depending on which client you have, that could skew things?
I mean, yeah. So it would totally lead to different clients just voting for different things all over the place. Like the goal, I think, is for it to lead to an equilibrium that generally satisfies most miners.
Okay. Yeah. And so for something like that, that would just be like a new EIP that could eventually be put in. But from what you said earlier, and I think from what other people have said, this isn't something that is bad enough that we need to have that be our focus over anything else in Metropolis right now.
Well, yeah, I mean, so it's not a protocol feature, right? It's just something that Geth would have to do in parity.
It's a miner strategy.
Oh, that's right. But even if you change the default mining strategy, unless you're forcing a reset every time they boot up to an updated Geth or parity node, that they would need to change it themselves, right?
No.
So basically, the suggestion was to actually change the gas dynamics encoded into the clients so that they adapt a bit differently.
Oh, yeah, sorry. And Arcady, do you have any comments on that from Parity's end?
I just want to say that I'm pretty sure most mining pools override the defaults and specify their whatever force or sequence that they see fit.
Yeah, I think what the problem with that is mostly because mostly pools define their own because the defaults aren't really sensible enough. For example, during the DOS attacks, there were problems that blocks took 5 seconds to process, and now obviously mining pools were angry about that. But if the algorithm would have adjusted automatically and would have brought down the gas limit to half of it, then maybe nobody would have cared. So it's again, I think it's a nice thing to actually give a possibility to the miners. Then obviously it's up to them if they take it or not.
Okay. But yeah, that is something that can be changed at the client level to at least anyone new coming in or updating who hasn't done their settings could have those new settings. Okay. Or I guess that's more, that's for both clients actually. All right, cool.
We wouldn't object against it generally, but an EIP will be welcome.
Okay, great. I think there'll be more discussion on that then. Any other comments? Okay, and then the last one, EIP 186, reducing the Ethereum issuance before proof of stake. If you go to the agenda and scroll to the bottom, the last comment outlines Vitalik, Alex Vandesand, and Nick's comments on that. So, Vitalik, since you brought up that in chat, you can start with your ideas on it.
This was the issuance reduction?
Yes, exactly.
Yeah, so basically, the proposal that I had was to do a one-time cut down of the issuance and target the amount basically so that the amount of issuance per second after Metropolis roughly equals the amount of issuance per second right before Metropolis. So in practice, if let's say the block time is something like 25 seconds when we do the switch, then the drop would be from 5 Ether to something like 3 Ether. And the idea here basically is that, first of all, I think it's having levels of issuance that are higher than current levels is from a security standpoint completely not necessary, and I would say it's even, especially given recent price levels, it's probably quite excessive and wasteful. From a more kind of political point of view, you could argue that pushing the block reward up to 5 and keeping the block reward per second constant are both kind of maintaining the status quo policies. And as far as out of those two, the lower one seems more prudent. And also, in the longer term, this would probably end up being the first decrease of several, where the next decrease after this would be whenever we end up switching over to hybrid proof of stake. And then the third decrease would end up happening when we go from hybrid proof of stake based to a full proof of stake. Though obviously the details behind the latter two are still in progress.
Okay, great. And then we'll just go with, I guess, Nick next. What was your comment?
I didn't know I was going to be asked for comment.
No, sorry. I was like, so you said on Getter, my own opinion has evolved. I'm tentatively in favor, because it's a step. Okay, actually, yeah, never mind. You didn't have the long comment. Alex did. Alex, did you want to comment on your stuff?
No, well, I don't think I need to read from that comment, but I like Vitalik's proposal of simply freezing whatever the issuance at the rate when we do the ice age. I think it's an interesting neutral approach. And yeah, and of course, we don't have any exactly target goals on what will be the issue on Casper, right? We know that it will be lower than currently, but we don't know how much, right? But I think that would help a lot, setting that.
Mm-hmm. Yeah.
Okay, so it sounds like it's about setting expectations and helping it not be too. Right now, it's not helping security with how high it is. It's to the point where it could be lower and still be fine.
Yep.
So would this go into Metropolis, Vitalik, or would this be after?
Yeah, so this would basically be simultaneous with the difficulty bomb delay.
Okay, so in that case, there might need to be, and let me look real quick. I think Hunter Island or whatever has a new. I think he either said there needs to be a new EIP. Oh, I see. Okay. Never mind. He just put a different thing about the difficulty bomb diffusion. So yeah, if we could either use this EIP or write a new one. I think this one was based on different assumptions and some figures from last December. So I might ask him or anyone else in this channel who wants to do another one based on Vitalik's suggestions. Or Vitalik, if you want to pick that up, it's up to you.
I have a question for V, and I think I had mentioned that on my comment. Supposing an extreme scenario where we postpone the ice age for a year, the year comes around and Casper, we are not ready for proof of stake yet, and then the bomb starts rising again, and the Ether price crashes to very low, let's say $10 or something like that. Would you think that it would impact or the issuance rate? Because in theory we should not be changing the issuance based on dollar price, right?
So I would say that at current levels, like basically intuitively speaking, right, the probability that my kind of instinctive opinion right now is that the 3 Ether per block rate should be safe with Ether prices anywhere above maybe the $20 to $50 range. Now, the 5 Ether rate, in that case, is logically speaking going to be safe at anywhere from the $12 to $30 rate. And I would argue that if Ether crashes hard, then it's probably going to crash really hard. And so the probability, like if we see that kind of hard crash, the probability that it'll land in exactly that sliver where the 3 Ether rate is not safe, but the 5 Ether level is safe seems fairly low.
Okay, thank you. Fair enough.
Okay, so yeah, Vitalik, did you want to write that up, or do you want me to just get Hunter Island to revise his?
Yeah, just like, I mean, like the EIP here is basically very simple, right? It's just like a one-time thing that says if the block number is greater than or equal to the Metropolis fork block number, then replace the block, basically multiply all block reward related parameters, including like base block reward, nephew reward, and uncle reward by a factor of x, where in this case x is a 3/5.
Oh, okay.
By default.
Oh, there's nothing. Yeah, there's nothing behind the scenes. It's just literally just changing it. Okay, no problem.
Yeah, I mean, like the only tricky thing is just to make sure that we change like all the constants, including the uncle and nephew stuff.
Okay, sounds good. So the last thing, Nick wanted to bring up EIP 658, which was involving embedding transaction return data in receipts. I'll put that in chat and get her, but Nick, you can go ahead.
Sure. So the basic thought is that up until Metropolis, it's been possible to know fairly, with fair assurance if your transaction failed or not based on the gas return, which people rely on, I think, quite heavily. With the introduction of the Revert opcode, that's no longer the case, and with current APIs, it will be very difficult for people to determine if their transaction succeeded or not. It's possible for a full node to re-execute the transaction and tell you what its return code is, but that's not possible for fast nodes synced, from before their pivot point, and it's not possible for light nodes. So this EIP proposes adding either the return data itself and a status code to the receipt in place of the intermediate state, which we were already deleting, or adding a hash of that value to the state. Sorry, to the receipt.
Yeah, so I think the only people who've commented on that recently have been Peter and Casey. And so Nick, Casey might be able to say this better, but I think he was talking about how this might mess up light client stuff. Casey, what was that one about?
Oh no, I was saying that in principle, it's possible to do transaction. Even light clients can do transaction traces.
Yes, that's true. However, it would be a very intensive, like the upper bound on that is very high for a light client, since a transaction could affect a contract with a lot of state and do a lot of operations.
Sure, yeah.
So the issue is that in order for a light client to figure out that the transaction that reverted, what happened there, is the only way is to actually trace it. Now, if that transaction consumed 4 million gas and touched everything, then the light client would actually need to download a lot of stuff for it.
Yeah. So what I'm curious for feedback on is, first, is this a good idea or is there a better option? And secondly, if it is a good idea, should we store the actual return data in the receipt field or should we store a hash of it? Briefly, storing the actual return data is simplest in terms of accessing it, but storing a hash has the advantage of the length of the field not changing and the data type not changing. But the disadvantage that you would then have yet another thing you need to sync, and you'd have to add a new message type to the wire protocol in order to fetch return data.
I personally prefer if only the hash would be stored. The reason is mostly because then the data structures don't have to change. So if we were to store the entire error message, then that means somebody might insert an arbitrarily long error message. So all of a sudden we need extra pricing problems and the data formats.
So I agree about that we need to consider pricing. I'm not sure that it's a problem because they already had to pay for the memory in order to return the data, and I'm not sure that moving it out of the receipt solves the problem because it'll still need to be stored somewhere.
So it is worth noting that in the context of a logs, we do charge 8 gas per byte of just like data that gets put into a log.
could we get away? I mean, it would increase the scope of this change, but could we get away with charging 8 gas per byte of data in return data?
That sounds like a. So that would have to be done in the top level call only, and that seems like a weird change. And
Yes.
But the question is, so the corner case that we want to solve is nodes figuring out whether a transaction failed or not. Do we really want nodes to explicitly know why it failed, or are we happy with them?
So in my mind, the main purpose is knowing if it failed, but if we're going to fix this, it seems to me to make sense to fix what I at least see as an omission of not being able to get return data from top level transactions.
Mm-hmm. Mm.
Okay. I haven't been able to look into this enough, Nick. Is this related to EIP 98 for med state from receipts, or is this a different portion of it?
It obsoletes 98 by using that field for something else.
Ah, okay. Interesting. Okay. Yeah, we can talk about this more on the EIP and in Getter. Does anyone else have any other comments on it?
So just to highlight the problem, imagine that you issue a so currently you create a transaction with 200,000 gas, and then you look at the receipt and you see that 200,000 gas was consumed, and then you know that it failed, and then you might want to trace it or whatever. The issue is that if with the introduction of the Revert opcode, let's say that 200,000 gas consumes only 50, and then you have absolutely no clue whether it was successful or not. Basically, you cannot tell whether it was successful or the transaction blew up.
Okay, any other comments? Okay, great. And then I did say we would go back to EIP 80. Oh, go ahead.
I'm sorry. So I'm wondering why the Revert opcode doesn't consume all remaining gas. Maybe it's just easier to make Revert opcode consume all gas, like all failures so far.
I think it's extremely valuable to have a way to like make transactions fail or make internal calls fail and return data without burning a huge amount of extra gas. So one very simple example is that if you look at a lot of recent ICOs, the majority of transactions end up coming in like after the ICO hits the cap or after it expires, and so they fail. And because of this, these transactions often end up consuming like 200,000 gas, when in reality they could have gotten away with consuming like half of that or possibly even lower, so, like possibly even something like 30,000. So I could see the Revert opcode actually like decreasing the effects that ICOs specifically have on network congestion by more than a factor of 2.
Okay, I understand.
I would make one comment here is that Revert shouldn't, in my opinion, Revert shouldn't like, so if you've used up to like 10,000 gas and then you call Revert, the cost should not be 10,000 gas because you are doing like, there's a bit of an extra cost to actually reverting the state. So it should be like 1.5x to 2x maximum, you know, or up to the gas limit. The amount of gas used so far.
I'd say, I mean, go ahead.
Oh, that's not something we impose at the moment. You can revert when you've only got, you can fail when you've only got one gas left. And it may actually be cheaper because although you have to rewind things in memory, it's stuff that you don't have to write to disk.
Yeah, like basically in all major operations, well, all you're doing is you're basically just going back through the journal. You're walking backwards through the journal, and you're doing a single memory operation for every single storage operation that you did going forward. So the ratio between memory and storage tends to be very high. So I don't think like the extra expense you're incurring is particularly high.
Yeah, fair enough. I guess if you run out of gas, that's a Revert as well, which doesn't cost any extra gas. I guess it's kind of the same thing. Yeah.
So also one thing we learned during these DOS attacks is that the costs for reverting is already priced into the actual operations. So if you do not revert, you kind of pay a bit more gas than if you would revert.
I see. That's interesting.
Okay. Let's see. All right, I think that's all the agenda items. Was there any other comments on that EIP?
No, but well, I would like to add on that it would be really good to get that decided pretty quickly now if we want what we want to use the receipt bid to for, and if we're going to reuse it as Nick has proposed. So all inputs, please.
Can anybody hear me?
Yeah, RJ, what's up?
Yeah, I was just I had a thought on it. Do we want to go ahead and encode this into the ABI at all, like an error type at all, and make this kind of standard at all with the revert? That is.
Do you mean encode the format that revert data should take?
Yes.
I think that's something that should be left up to ERCs and contract level standardization. I'm sure Solidity will end up implementing some kind of at least de facto standard for throw when it supports it via revert.
Okay, that's all my questions.
Actually, I also have a question. So
okay.
If revert wouldn't return any error message, but there was some way to get to get on the interface the exact revert which ended up reverting, wouldn't a annotation just similar to the NatSpec, or actually part of NatSpec, would do the job? So isn't the point of returning something just to identify the error? So having a free text error message, I think, is a huge overkill. And I agree with Peter that the hash might be enough, but even the hash might be too much. So just some way to identify which of the reverts got executed would suffice, wouldn't it?
I think it's helpful to look at it the same way you would an exception in an OOP programming language. It may contain arbitrary information about the reason that the call failed. And I don't expect that it will be a text string normally.
But if that information would never actually be processed by a contract, if it only needs to be displayed to a human, then doesn't it belong to annotation rather than, EVM code?
Sorry, say again?
So if what revert returns as a free-form text will never actually be processed by a contract, by another contract, its only purpose is to be displayed to a human.
Well,
then doesn't it belong to annotation rather than EVM code?
No, why do you say it would never be processed by another contract?
Well, because you don't want contracts parsing error messages.
No, again, it's not an error message. It is the return data in case of a revert, the same way the return data from return is return data. So if you throw an exception, then it would contain the binary encoding of that exception's fields.
I see.
I am wondering whether, like, a third option for EIP, what number was it again? The one I just proposed, 658, would be to simply use the med state field as a return code 0 or 1 and emit return data. I'm loath to do that personally because I think it would be very useful for people to be able to access return data from a transaction, but that is more a nice to have than an essential fix. So if it turns out to be impractical to embed the return data directly or to add new RPC calls, that could be a simplest of all worlds approach.
So just a short comment from me. I think it would be very valuable to have the return data both in success and failure case for transactions available.
Do you have any opinion, Christian, on whether it should be included in plain text in the receipt or as a hash?
I don't think that, I don't think a hash would be quite useful. I mean, I would say we should see it in the same way as events are used, right? I mean, they can also include plain data.
I guess the difference is we don't explicitly charge for return data, or for storing return data, because we don't presently. We charge for the memory expansion required to return it only.
Sure, but that can be changed on for a top-level transaction, can't it?
It can be, but as Vitalik pointed out, that's an odd exception to make in terms of gas costs.
So personally, I would be in favor of reusing the receipt feed for a hash in Metropolis. And if we're going to reuse the receipt feed for actual plaintext data, I think it should be postponed to fork after Metropolis.
If we were going to do that, then I would suggest using it just for a return code and then adding return data as a new field in the receipt post Metropolis. Because if it's a hash, then you pretty much have to add the get return data and return data wire level protocol options, even just to be able to determine whether it's succeeded or not.
Well, not really.
No.
So if success means that the return code is 0 and no data is returned with it, then you could always check whether it succeeded or failed. Just you wouldn't be able to get the failure.
Unfortunately, there are a lot of existing contracts that get called externally that return data, though.
Well, yeah, well, this is another question, whether we want that data to be available and accessible or not.
But I mean, even if you don't care about making it available, you won't be able to tell if it succeeded or failed if the hash includes that return data, because you can't rely on just two values.
Oh yeah, but my point was that it wouldn't include that data in that case, that if it was successful.
But isn't that what I just suggested?
Sorry?
Well, I suggested that if we were going to talk about adding return data field later, then in the meantime, we should only add the status code, not the hash of the return data. If we add the hash of the return data, then you have to add a get return data wire protocol call in order to be able to tell even if it succeeded.
Well, so I thought that a middle road would be to add. So basically, you would add nothing or keep it all zeros if it succeeded, or whatever special opcode, and add the hash of the failure. And then you could add the network code to actually figure out the failure.
That seems, I don't know, it seems like an odd special case to not return the hash of the return data if it succeeds, but return the hash of the return data if it fails.
Yeah, well, I guess it's, to me, it's the same. I don't really care that much, but just that if we return everything, if we return the hash of the of the return data on a successful call too, then we really do need that extra network packet.
Yes, I agree. So I think, but Martin was suggesting that we could return hashes now and add plain data later. But I would say that if we're planning to add plain data later as an extra field, then we should just return status code only now and not bother with hashes at all. I mean, maybe even we could add plain data as an additional receipt field now. I don't know how much that would add to the complexity. So in that case, intermediate state would be repurposed as return code, and then a new field would be added to the end with return data.
Okay, but then the size of the intermediate hash would go down from 32 bytes to essentially 1 byte.
Yes, but you could still unmarshal it into the same type, couldn't you?
So I don't know, this is a protocol. I guess this is an implementation detail, but so currently, at least in Go Ethereum, the field size is validated when RLP decoding. So if we were to say that the RLP size should be 1 byte exactly, but we allow unmarshalling it into 32 bytes, then I can see some things going wrong.
Okay, I mean, we could specify 32 bytes of zeros, but that seems wasteful.
Well, yeah, but I guess if we consider adding a second field with the plain data, then we can add the Boolean field and just drop the intermediate hash.
As in drop it entirely, or just specify that it will be set to zeros? Because I don't think we would have, with 86, was it 86 or 98? I don't think we would have filled it with zeros, would we? So we would have already encountered this issue.
Well, so my only point is that if we're going to do modifications on the structure anyway, then we can do arbitrarily invasive modifications because it doesn't matter.
Right, but I'm trying to compare to what the default is, which is 98. I don't think either of the proposals in 98 called for filling the net state with 32 bytes of zeros, so we probably would have had to make changes regardless.
Right, as far as I know, at least the proposal implemented in Go Ethereum is to drop the field completely.
Okay, so that's also a structural change then.
Yes, it is.
Okay, so does that mean people are in favor of just changing the receipt to drop that field and add 2 new ones?
That seems like I'd still personally prefer to find some way to not make structural changes.
But as Nick points out, it is already a structural change with the drop-down of the receipt roots.
Well, I mean, unless we use that exact same 32 bytes in specifically in some way, or of course,
sorry, go ahead.
Yeah. Either a hash. Sorry.
Yeah,
I was gonna. Yeah. Or like the slightly more structure changey, but not too structure changey thing to do would be to replace it with some other number of bytes, so like 33 bytes if we want to byte a bit and a hash, or if we still want a variable size thing, just like make it a byte array.
So if you're going to change it from a fixed 32 byte to anything else, then that's a structural change. It doesn't matter then how much you change it.
Yes, but it's a specific kind of structural change that's easier to implement because it's backwards compatible in the sense that it goes from being a 32 byte array to being a general byte array, and 32 byte arrays are a subset of general byte arrays.
Fair enough, but if you have a strictly typed language, then you are changing the type from a hash to something much more relaxed, like byte slice.
Okay.
Okay, I think that wraps up that. Was there any other comments, Nick, or can we bring that to the EIP?
I think we should take it offline or take it onto the EIP, yeah.
Yeah, if you could do any comments on your EIP or 98 that either summarize or any conclusions that partial conclusions we've come to, that'd be excellent.
Will do.
So that's pretty much it. Is there anything else anyone wants to say or anything to bring up? All right, so before we go, focus on EIP 86. Let's try to get that wrapped up because that'll help with testing and making sure that we can get a deadline set for Metropolis. Go ahead and look at Nick's proposal and also at EIP 186. That one's less controversial, 186, as far as Vitalik's formula he proposed. And then finally, if you haven't purchased DevCon 3 tickets, go do that. And yeah, just like reach out if you need to know the website or anything like that. But go ahead and get them before they're gone. All right, thanks everybody. See you in 2 weeks.
Bye, guys. Bye.
Bye-bye.
Bye.
Bye-bye.